Okay, so for Lab 3 Tinkercad, this is the IC unit 74, 73 and 75, and you need the power supply to power the board. So this is positive, this is negative, so I connect a positive to the top and negative to the bottom. Then I pull this positive to here also, so this line is positive also, this line is negative also. Okay, then let's power the IC. So this is the power pin, so it's need go to the positive, and this is the ground, so go to the negative. Then let's say I'm using second DV flops. So reset is an active low, so I need to pull it to the high. So I connect to high. Then another one is set. Set, I need to put it to high also. Okay. Then this is the input. Input is see whether I want to give it 1 or 0. Then this is the clock. This is the output. So output I need to go to register, then register go to LED, LED go to ground. So I completed the output. Then now is the clock and also the input. So for clock and input, we need a switch to supply the clock. So I'm using the slide switch. So the slide switch is very simple. This is your, where's your clock pin? This is your clock. So you bring your clock to here, the center. Okay, then this one you go to 1, and this one you go to 0. So if my switch is over this side, so means my 1 is connected to this clock. So if I slide the switch, let's say I start the simulation, then I slide the switch, it means it's connected to terminal 2, which is ground. So I can select whether it connect to 1 or ground. So by doing so, basically I'm changing the power. So let's say the slide switch is initially connected to the 5 watt or the positive. Then my power supply is at 1. So if I slide the switch to ground to 0 watt, then it will drop to 0. So I'm basically creating a falling edge. So this is the thing you need for this the fifth floor is a rising edge also. So you need to start with 0, then you slide it to 5 watt, then it will go up, so it will be positive edge trigger. Okay, so this is the way you generate the clock pulse, by sliding to 0, connect it to 0 or connect to 5. Then you're able to create the clock pulse manually by your self, by slicing the switches. Okay, so this is how you're creating the clock. Then the output, let's say I connect it to this input, right? The input, let's say I connect it to stop simulation first, then I connect it to 0 first. So I connect it to 0 first, then let's say I start my clock, it is at 0, right? So even I clock it, it's still at 0 because I set my input to 0. So let's say I set my input to 1, then I start my simulation. It is lights on already, right? Want to make it more visible, we can put another slide switch for our input. Okay, so let's say this is your input. Okay, then this one I connect it to plus, this one I connect it to minus. Okay, then I start the simulations. Because I connect to 1, so this say I connect to ground, then I give them a clock pulse, it go to 0 again, right? So let's say I connect to, so now I'm at 0, so even I switch my clock, I give a clock pulse, it remain at 0, right? So if I go to 1, I give a clock pulse, it will light on. So this is how you try the DV flops, right? It depends on what is your input. If my input is 0, if you give a clock pulse, it will follow your input. Okay, so this is the DV flops. Then the next one is the 73, which is the JK. You can do the same to the JK. So for JK is here, the clock pulse is pin 1, so the VCC is pin 4, 11 is ground. Okay, 4 is a VCC, so this is a VCC, so I connect it to VCC. Then this is the ground, so I connect it to ground. Then this is the clock. So I connect it to here. Okay, so let's say I'm using the 2 also. Where is my one clock, one J is here. So yeah, I have to connect the clock. Clock 1 is here, so I need to connect it to the center. Okay, this is the clock. I think better connect to the same. So this is the clock. This one is the clock one. Then J1 and K1, this is J1, I need another for K1. This is my K. This is J1, K1. So I move this one to here. K1, I put it to center. Then this one I put positive and a negative. I think I need to connect this one so that they are linked together. Okay, then the next one is what? Output. I need LED and a resistor. Where's my output? Is here. So I'm able to rotate my resistor also. Okay, this is my resistor. Go to the positive, then go to the ground. So this is my inverter output. I need to connect output 1. So the ground connected, the K2, this is, I'm not using the K2, J2, clock 2, reset 2, I don't need to use. Where's my reset? I need to pull the reset 1. Reset 1 is the reset is a negative flow, so I need to pull my reset pin to 1 so that it won't do the reset. Okay, so now my J is at 0, so if I put this here means I go to 0. Then my K is at 1. If I give a clock pulse, the LED will remain at 0, right? So if I give my K to 1, my J to my J to 1, this is my J. My J is connected to this one. So I use my J to 1, then my K to 0. Okay, it should light on, right? Right, it's light on. I give the clock pulse, it will light on. So if let's say I give both equals to 1, so if JK flip-flop I give both is 1, it should suppose it's toggle, right? So you can see when I keep on giving them the clock pulse, the LED is keep on toggle for your J flip-flops. Okay, so this is how you do the connections. Remember, you need to give the ground to ground, VCC to VCC to 5 power to 5 volt. Then the reset, remember, is active low, so you must always give a 1 so that it won't reset. Then this is the clock. You need to give a slide switch. Then the J and a K input you need to give. Then the output is using a LED. So the output is connected to here. Here come to these terminals. Then the next terminal go to positive for LED. The negative go to ground. So by doing so, you complete the circuits. Then by starting these two, you are going to connect your K or J to 1. If you at this side is 0, 0 or 1. Okay, so this is how you test your JK flip-flops. Then the last one is your D latch. So this is your D latch. So your D latch is this one. So the same thing, you need to connect the VCC and ground, which is pin 5 and 12. So it is my power, it should be here. Power, I go to VCC. Then ground, go to ground. I think I need to connect it. If not, it won't connect it. Okay, then the next one is output 1. So output 1, I need an LED and resistor again. Okay, LED. go to ground. Okay, then the output 1 come to here. Then output 2, inverted 2. Enable 1 and 2, you need to enable it so that it only will work. So I connect it to 1. Then the ground I connected inverted 3, output 3. So this is the inverted output 1, input 1. So I need the slide switch. The slide switch is connect to input 1. So I connect my input 1 to here. Then this is go to 1. This is go to ground. So let's see how. So that now my input is 1, so it's light on. If I switch to 0, it go to 0, right? So latch is very simple. They don't need the clock pulse. Whenever you change the input, they will straight away change. But in the condition where your enable is at 1, you enable this IC. So let's say I put this one to 0. I disable the IC. Right. Then I start the simulation. I try to switch. It won't operate, right? You need to enable your latch, then only it works. So this is all these 3 IC, how you going to do the connection and how to make it works. Then you can start to do your assignment, which is submit the submission for the sequential counter by using JK flip-flops. Okay, so 2 bits, so means you need 2 JK flip-flops. The same thing, if you need 2 JK flip-flops, how many IC you need? Suppose it's 1 only, because in 1 then you have a 2 JK flip-flops. So 1 IC is enough for you to do the 2 bits synchronous up counter. Okay, so that's all, and thanks.